Hi everybody, welcome back, and I hope you enjoyed lunch. So we're going to kick off this afternoon sessions talking about Fargate and showing you some of the features it can do. I've got a little demo for you as well, which fingers crossed works. So we're going to talk first of all about why did we build Fargate. You'll notice some concepts brought over from the State of the Union chat this morning. And then I'm going to do a bit of a deep dive into the internal workings of Fargate and how it works and how you build your application. And then we're going to put that into practice and actually do a demo and launch a little chat application. And this chat application, you'll actually all be able to log into from the audience if you've got your phones on you or your laptop, so you can put rude messages up on the screen while I'm speaking. Please don't. You can put messages up on the screen while I'm speaking. So first of all, let's talk about the motivation. We've already talked about this morning. We're saying at first we had EC2, and this is a great way to quickly launch and provision compute resource in the cloud. But then people wanted to use that resource more densely. So Docker came along, and we could build containers, and we could run multiple containers on an EC2 instance. We could get better bang for our buck on cost. We could put more containers on the same host, run more workloads without them interfering with each other, and better use our CPU and RAM resources on there. So that was great, but it was very, very difficult to manage that over a large fleet of servers. And that's where, when the admin came along and said to us, please make this easier for us, we decided to build ECS. Now, why am I talking about ECS? This talks about Fargate. Well, Fargate is kind of an evolution of ECS. It shares a lot of the same principles and concepts and ways of building. I touched on this earlier. You can actually take a ECS configuration task and you can change one line in it and deploy into Fargate and vice versa. So they share a lot of compute principles. There's a few little differences we'll point out as we go along, but we'll get there. So why is managing a cluster difficult? Why do I keep saying this? Well, let's look on the host that we're running. We have an EC2 instance. On there, we generally want to keep this kind of minimal. We've got our operating system, we've got the Docker agent, and then we've got the ECS agent. The ECS agent is the thing that talks back to our management control plane and says how much resource that EC2 instance has got. It also reports on the health of the tasks running on there and any other constraints we put in. It's also responsible for starting the Docker containers on that host. So it's a bit that does the communication between the management control plane and EC2. But if we're bringing these EC2 instances across ourselves, we've got to manage that. We've got to patch the OS. We've got to make sure we're running the latest version of the Docker agent and the ECS agent is up to date. Now, a lot of this is quite simplified because if you use our AMI, there's the SSM agent on there. And in the console, you can actually just click things for like upgrade ECS agent, and it'll happen for you magically in the background without you having to SSH into each box. But OS updates and Docker agent updates, you've still got to manage that. And this all becomes overhead and time consuming from an operations point of view when you could be out building the cool stuff. Instead, you're looking after the current infrastructure and you're not moving forward. Just re-saying what I said there. Doing this across a fleet is huge, and also picking the scale that you need to run at and the right size of instances. It's all time consuming, it's all quite complicated, and it's hard to get right. You have to try several iterations before you've got the perfect size cluster and you know when your auto-scale events are going to be. It's quite hard to manage all that yourself. Elastic Container Service made this a lot easier. But then Fargate made it even easier because all you're focusing on now is your containers. No longer do you have to look after all this. Just instead, you've got Fargate. You talk to ECS as per normal. Same tool set, same command line tools. But we just focus on our containers. So Fargate basically manages all your management infrastructure and your worker nodes. It's elastic, it scales up and down seamlessly in the background, something you don't have to worry about yet again. There's no scaling for you to do, no consideration for you to have to do this. And it's really, really well integrated with the AWS ecosystem. IAM permissions for tasks, elastic load balancer integration, with the AWS VPC networking, which is the only networking mode that works in Fargate, you get your own elastic network interface into AWS. Now that's kind of important because it's very low jitter, low latency into our network, and that means you get a really, really good speed on your connection to your tasks and your containers within. Also, CloudWatch for login, it's integrated, but it's very, very easy to change to another login model. FluentD, for example, it's just a configuration change as you go along and build your task definition. But by default, all that's there and very, very easy to use. So, what do we have here? We have our image repository, ECR. Then we used to have a way of hosting on EC2, and we managed that using the Elastic Container Service. We're bringing out EKS, that's another management layer, yet again uses EC2 for hosting. Fargate fits in here. Fargate is actually the hosting section of this. So whilst you don't manage EC2, it sits on that same tier. That's where you've got to think about it in terms of accessing Fargate and when you do stuff. So let's talk about what we're going to build first of all. I'm going to go through and I'm going to show you all the concepts that we're going to use in this particular demo. We're going to look at permissions, we're going to look at load balancer, connectivity, and running containers. And I've also dropped in at the last minute service discovery, which is relatively new, so let's keep our fingers crossed that bit works. So we're going to build a chat application, and it's a very, very simple socket.io Node.js application. I'm going to run it in multiple containers on the front, linked to a load balancer. And then at the back end, I'm actually going to run Redis in my Fargate cluster just so I can use service discovery. If I was kind of doing this in a production environment, I'd probably consider using something like Elasticache Redis there, so I don't have to manage that side and backups and the cluster and the availability and the failover. I'd use a service to abstract that. But for this demo, it's going to be great because we're going to use the service discovery so our front-end containers can find the Redis host at the back end. And you'll be able to test this by logging in and doing stuff. So let's have a look at the constructs of Fargate to start with. It's all very similar. You write a task definition. A task definition is where you define your application. You say which images you're going to use for your particular container. You put in memory constraints and CPU constraints in there. We then have a cluster. And within that cluster, we've got a isolation boundary. So if I create a cluster named production and I launch a task in there, if I launch that very same task in a cluster called dev, there's an isolation boundary. Those containers cannot cross and talk to each other unless you go in and explicitly do some complicated things to make them connect. And you've got IAM permissions there as well. So our task is going to run in our cluster, and that runs by a service being created. The service is what the ECS side of things does, the Fargate management control plane. Tells our cluster we want to run a few of these tasks. It might be we want to run multiple copies of this task throughout our cluster. It will also talk to the Elastic load balancers, and it will also keep track of the health of those tasks. If one of those tasks become unhealthy, it will replace it somewhere else in the cluster for us. So it's got a lot of important jobs to do, the service, and it's what basically makes sure everything is working as should. So this is very, very simple task definition snippets. On here, I've got a family. It's an immutable document in here. I've versioned it with the name chat for my family, and where I list name, chat app, and an image, and the image is my Docker repository image, in there I could put up to 10 containers, and I could configure them differently. And in there I can open different ports for each containers. I can give them different CPU and memory constraints at a container level. I can also give the entire task memory and CPU constraints as well. So each container definition needs a name, image URL, and can go in to more detail, which we will do in a minute. I'm quickly going to tell you about registry support in Fargate while we're at it. So we support ECR naturally, because it's It's our product. We also support public repositories, so things like Docker Hub. In fact, the Redis container I'm going to pull down comes directly from Docker Hub. And we're also working on integration for third-party private repos as well. So the Fargate or the ECS system will be able to log into private repositories, be that private Docker Hub or something like key.io. It'll be able to log in there. I'm not saying quay.io for you over there, our American friend. So that integration will be coming soon. Right, let's dig into the compute side of this. What's happening now? How are our containers running? So I mentioned that our containers can have CPU limits. Now, one virtual CPU equals 1,024 CPU units, and our memory is measured in megabytes. So let's add some task level resources here. My task, and that's 2 containers in this example here, can maximum use 1 virtual CPU and maximum use 2 gigabytes of memory. On a container level, I've actually said I'm going to use 1/4 of a CPU for this first container and 512 meg of memory. So that's a container restraint, not a task restraint. So you can get quite granular on how you restrain things here. So if you've got a container that doesn't need very much resource, tell it in this level it doesn't need much resource, and the container that needs loads, let that fill its boots and use everything. Now, task CPU memory configurations. There are 50 different configurations you can actually use here. So it starts off at 0.25 of a virtual CPU, and they can come in 512, 1 gig or 2 gig memory sizes. And then we can jump right up to the big boy at the end here, which is 4 virtual CPUs and 30 gigabyte of RAM. That'd be a pretty big container, and if anybody's got a use case for that, I'd love to hear it, because I want to know what you're running in containers that takes that much. But it'd be great fun to see it. Now, pricing-wise, you're going to pay for what you provision, and you'll build at a task level. So if your task is 5 containers in, and between that you're using 2 virtual CPUs, you'll get charged on the 2 virtual CPU total and the memory total that you're using. There's also per second billing. It's a 1 minute minimum, but if you switch your containers off 1 minute 20 seconds in, you'll get charged for 1 minute 20 seconds worth of runtime there. Let's have a look at the network. So when you launch your Fargate tasks, you launch them into subnets. In my example, I'm using all 3 availability zones. I've got a subnet in each availability zone. You'll see that soon. And what happens to that Fargate task when it runs? An elastic network interface gets attached to it, and that will get a private IP. Optionally, it can have a public IP as well. So that private IP will allow you to natively access other EC2 or load balancers or DynamoDB or other endpoints in your VPC, because you've effectively got a network interface in your virtual private cloud. So you've got an IP address that matches the rest of your network. So you can use security groups and network access control lists to do your normal configuring of access through your network. The internet can come on a public IP direct to the ENI if you want. It's also possible to do this in a private mode, which we'll touch on in a minute. Now, let's have a look here. When we configure our task definition, right at the top of the task definition, we have network mode, AWS VPC. This is the only mode that works with Fargate. ECS supports more. It supports bridge mode. So if anyone's ever done anything with Docker before on their laptop, bridge mode is very similar to that. You share the network interface, and you have a virtual interface that comes up on your machine, and you route traffic via that. Host mode basically pins everything to the host elastic network interface. Host and AWS VPC are faster than bridge, but AWS VPC is far more separated, and each task gets its own network interface. So in my opinion, it's one of the nicest modes, and it also seamlessly extends your VPC into your container world, which makes the simplification of security rules and network access control lists so much easier. You don't have to jump through hoops to connect a container to a EC2 instance or to an RDS instance. You can just use the normal constructs we have, which are security groups and network access control lists. So this is a little bit of example of when you launch. You can specify what subnets you're going to put your application into if you're doing this from the command line. In this case, I've just picked 2 subnet IDs here, and I can specify security group as well for my launch. We're actually going to launch in CloudFormation. I'll tell you why in a moment. So, internet access. Now, the Elastic Network Interface is used for all inbound and outbound traffic for that task, and that includes pulling the images from ECR or a public repository. Also, pushing logs out to CloudWatch. That Elastic Network Interface is used for that. The underlying host doesn't handle any of that traffic for you. It all goes through your task Elastic Network Interface. And this is great for separation in one way. If you've got multiple tasks running on the same host, they've all got their own network interface. Network-wise, they're not going to be competing for each other for resources. So, 2 common setups. We have private with no inbound internet traffic, but allows outbound access to the internet. And we have a public task with both inbound and outbound internet access. So let's have a look at a private task setup first in diagrams. We've got our normal VPC setup here. We've got a private subnet, and we're going to use a public subnet here. And that gateway, we've got outbound access to the internet through the gateway, but there's no direct inbound traffic into this task going on here. Now, if we want to make that a public task, we could run a Fargate container in the public network, give it Elastic Network Interface, and give it a public IP address. We set our security groups up and our inbound security rules, and we allow access direct into that container from the internet. Now, what I do in my example is kind of a mix between these two. I'm just going to roll you back to this one. I have a setup like this. I run my Fargate tasks in private subnets, but I have an Elastic load balancer in the public subnet that connects through to this. And that's a similar construct I use whenever I'm building anything in AWS. In my view, public subnets should hold NAT gateways, Bastion hosts, and Elastic load balancers. If you can avoid it, don't run servers in your public domain. Obviously, if you're going to run a VPN server, that's got to be there. It's got to have public access. But don't run servers in your public network. Run it in private. Use load balancers to point pinholes through security groups into the private network. This is great for security. So let's fast forward through that again. Elastic load balancer configuration. So we can put that in there. First of all, we give our container a port mapping. And then when we create our service, we can tell it to go to a current load balancer. We give it the ARN, the Amazon Resource namespace. We tell it what container we're going to connect to and what port. Our service then is responsible for telling the load balancer about each version of the task that's spun up. So if we're running 3 copies of that task, this service will basically register them all with the load balancer as we go through. Here it is. This is how I set it up. I knew I had the slide somewhere. This is what I do. I have an Elastic load balancer, or ALB in this case, in the public subnet, and everything goes through to a private IP in the background, like that. So let's talk about storage quickly. I'm not going to use any storage in my demo, but let's talk about it very quickly. So we've got the ephemeral EBS-backed storage, and that's provided in the forms of, you've got writable layers for storage, and you can have volume storage as well. You could attach an EBS volume direct to your container. So the layered storage, if you know how Docker containers work, which is going to be covered in the next session now, you'll see how this works in that. And by default, each task has a 10 gigabyte storage for all the containers on there. Share that 10 gigabyte worth of space, even though the containers are logically separated. So if one of your containers uses a lot of that space, the others can use less. is what I'm trying to say there. Once you stop the containers, that ephemeral storage disappears. It's gone. So you lose that. If you want persistent storage, you're going to use volumes. And you can have a mount point, whether that either be an EBS volume or an EFS mount that you want to put into your containers. You've got lots of options there. Or if you want to spin up your own cluster FS cluster somewhere and connect that in, you've got lots of options here. So let's skip through IAM permissions. So I talked about IAM permissions very, very briefly. We've got different levels here. We've got cluster permissions. A cluster permission is what access you as developers have to do stuff in that cluster. Can you start containers? Can you stop containers? Can you create services? Can you scale? All those kind of granular configurations and access controls that you need. That's your access into ECS and into Fargate. We then have application permissions, and that's what these containers can actually do. And you can grant a IAM role to your entire task, and then each container inside can also have a task level permission on there, which we'll cover in a second. And then we have some housekeeping permissions. Now, in Fargate, these are what we create automatically in the background. And this is to allow the Fargate host that we create and manage in the background for you to reach in and do things like pull your images from your ECR and push to your CloudWatch, create elastic network interfaces in your account. That's what these permissions allow Fargate to do. It also allows it to talk to the load balancers. So cluster permissions, it's something that you can have a look at the example here, and you can set up different access in here. This one would let you run a task within a particular cluster, and if that cluster's named as well. This one here will only let you read the tasks and describe the tasks that are running in the cluster. It won't actually let you start any or delete any or scale anything. So you can get quite granular in this as you go along. Obviously, they're very, very simple examples. You can have much bigger policies as you go along this. And many more, like it says on that slide there. So application permissions. If we look at a task role, if you want your application to do something, we're going to create an IAM role, and that's going to give permissions to that particular container. In my example, I'm not going to actually do any extra permissions, but what you could say in this is that if I enhance my chat container so you could upload an avatar, if I want to save that avatar in persistent storage somewhere, I'm going to write it to S3 as my cheapest option for storage. So I would give my container permission to write those little graphics out to S3, and then my application could consume those images from there and serve them to the general public. Let's have a look at one of these here. So this is a task level permission that I can put in here, a task role ARN. Now we can go a little bit deeper here. This is basically what allows your application to access AWS services without having keys embedded in your code. So if you've ever spun up an EC2 instance and had an IAM role on, it's the same thing. Let's have a look at our housekeeping permissions. We have an execution role, and that's used for pulling images and pushing CloudWatch, and also ECS service linked role, which does ENI management and ELB management. These are created for you in the background. They're immutable. You can't change them. So let's click through these, because I really want to get onto the demo and show you the demo, and hope that CloudWatch is going to be nice to me today. So our execution role, if we have a look on this as well as a task role, we can have an execution role where we can give it read-only permission to certain to our ECR, so we couldn't push images back from say our Fargate cluster. It depends if you want to use anything like automated build tools in your Fargate cluster. The linked role here, we're going to quickly skip through these so we can get to the demo as well. Sorry, I didn't mean to go that fast. So we're trying to get rid of the need for API keys in code. And I say this a lot in every talk I do about every service. Please don't put your API keys in your code. All it takes if you're using things like GitHub is one little misconfiguration to accidentally make your repository public, and there are bots that scan GitHub all the time. I think GitHub said something like it's 30 seconds after you make a repository public with your API keys in, that those keys are discovered and consumed. So if it was me doing that, I'd find your API keys, and if they had a lot of permissions in there, I'd spin up a load of Bitcoin miners and GPU miners and cost you a fortune and not really cost me anything. So be very, very careful with that. Users and IAM groups are for us, for human beings, and you have API keys for it where necessary. Roles are for instances, functions, containers. Don't put API keys in code, please. So visibility and monitoring. By default, we've got the AWS logs driver. So any of your containers that output to standard out, we collect those logs and we push them into CloudWatch logs. It's really, really simple to do, and I'm actually doing it in my demo, which is quite nice. So we create a CloudWatch group. In this case, my group is called Chat App. I've set a region of where I'm going to push my log to, and then my stream prefix for this is going to be Chat App as well. And you've got to remember to add permissions for that particular stream to your execution role if you've locked things down. This isn't actually my Chat App, but this is what it would look like. You'd have, if you log into the CloudWatch console, you'll be able to search for your particular log stream, go through, find your logs, and you've got centralized login. So if you're running multiple versions of your task and your containers, they all get aggregated together and you can search through them very nicely and easily. There's other visibility tools here. So I mentioned this earlier, ECS emits a ton of CloudWatch events. There's a lot of things going on in the background, and you can look in there of what's happening in your infrastructure and in your entire setup. So have a look at those. And if you're using ECS, not Fargate, you can do things on top. There's an open source project called Blocks, which is a way to like extend your scheduler and do some cool placement of your containers. And also we emit CPU and memory utilization metrics, and we push those into CloudWatch on a task level as well, so you can see how much memory and CPU your task is taking. Right, we're going to do the demo. So I'm going to switch over now. I'm going to mirror my screen and drop to the console. One last thing I want to say is I'm going to use CloudFormation for this because, in my opinion, everything you deploy should be templated. Whether it's CloudFormation or Terraform, I don't mind. It's up to you. You've got options. But the beauty of this is when you see when I launch my stacks, I'm calling this a production stack even though it's really a demo. If I wanted to make a brand new copy of my stack, I change one variable and I can launch an identical environment for doing some dev and debug and testing and digging in deeper by changing one variable. Now that's really, really powerful, and it makes crash recovery better, it makes development better, it just makes your whole life cycle management of containers better. So CloudFormation or Terraform for the win. Right. Let's drop over to my browser now. So I'm going to now unmirror my screen. Here we go, and I'll make this a little bit bigger for you as well so it's easier to read. Okay, so I'm going to start off and tell you what I've already got. I've cloud-formed a VPC. It's a network, it's a 10.0.0.0/16 network. I've got in there 6 subnets, 2 in each availability zone. I've got 3 public subnets, I've got 3 private subnets. And on top of that, I've exposed a load of variables, so I can find out in my outputs, I can find out the name of my subnets, for example, public subnet 1, public subnet 2. I can find my VPC ID. So I can consume these outputs now by this export name at the end here in my other scripts. And the first one I've got, my other CloudFormation here, is to create myself a Fargate cluster, which sounds crazy. I've already said there's no infrastructure. What am I creating? I'm creating a namespace, basically. And if I have a look in ECS, you can see my cloud-formed Fargate cluster. That's because it's cloud form. That's why we've got that big long UID on the end of here. And one thing to notice here, we give this view. You can see how many tasks and services we've got running in Fargate type. I mentioned we could have hybrid clusters. I want you to notice we've got no infrastructure running. We've got no container instances. I'm not cheating here. I'm using Fargate. I'm not using any EC2 ECS instances in this case. And one thing that won't make sense until I go through and do a bit more of the demo is, just note I've got 2 hosted zones in my DNS at the moment. I'm going to do some service discovery that's going to create me a new hosted zone. These hosted zones here are digillution.io and production.digillution.io. Quite a mouthful to say. They're the only 2 zones I've got. Now, the first stack I'm going to go and create here is my Redis master service. I was hoping to bring some Redis slaves to this, but I couldn't get it working in time, so we've just got a Redis master running. Please forgive me. And I'm going to go and CloudForm this. Now, I've stopped it deliberately on a point on this. Template error. That's never good. Unresolved dependencies service name. Let's fix this live. Let's try this. So, always good fun. I know what this is. I was messing about with it last night at midnight. Never a good thing to do. So let's have a look at our Redis cluster. In here, I need an extra configuration. Now, has anyone used CloudFormation before? Excellent, a few, that's good. I'm happy to hear that. So this is a templating language, basically, that allows us to define our AWS infrastructure. And in here, I'm just going to put a random value in. I don't believe it matters. So I'm going to save that. Right. Let's try that again. No. Failed to upload. Let's reload CloudFormation. I've got a backup plan to get out of this, don't worry. Capital letters. Yes. See, what I was doing, I was hoping you'd find that and pointing out it was a test, honest. Can't you tell this is my last session of the day? Default, there we go. Let's try now. See if we get an upload error again. Whoa. Well done, guys. You're actually the most observant audience I've ever had. This makes my life easier. I'm normally panicking at this point. String, here we go. Did I get that right? Somebody laughed. Did I get that right? Excellent. Let's try it. Here we go. This is looking better. Right. I'm going to create Redis master. I've got some CPU and memory constraints here. I've also set up the port for Redis, which is 6379. I'll put these in as defaults. A lot of this doesn't really matter. We're going to go through and just consume all this. I'm going to skip over this because at the moment I'm not putting any particular IAM roles or permissions in. As this demo matures, it'll get some of those in, and I'll start doing what I preach is best practice. So it will get updated. So I'm going to go through and create this. And I'm going to show you what's happening in the background. Now, I've deliberately stopped at a certain point in this creation. I've only created a task definition. I've not created a service on top. And that's because I actually want to build the service in front of you and show you some of the new little bits and pieces we've got built into Fargate and ECS with service discovery. So what's going to be happening here, we've got a create complete. Slightly relief there. If I go into ECS now, I'm going to go to task definitions. And in here, I've got a task definition called production. You saw me type that after I got the default value correct. So have a look in production here. And I've got a task definition built. My networking type is AWS VPC. We can run on EC2 or Fargate, but I'm saying this is a Fargate task that I'm running. I've got some memory constraints. And then I've got my container definition as well, which is that I'm going to use the Redis latest image. That's going to get pulled down from Docker Hub for us automatically in the background. There's no other real things I need to do with this. What I need to do is turn this into a service. So I'm going to hit create service. I'm going to let this settle a minute, otherwise you get an error on the console. If you notice that, if you're too quick, it says it's not compatible, and then it decides it is. So I'm going to hit Fargate, and the task definition I'm using is production. The platform is going to be the latest one, and my cluster is a cluster I've preformed. On here, I'm going to give it a service name of Redis master again, and I'm going to say I only want one copy of this task running. I only want one Redis container running. And I'm going to hit the next step. Now, if I drop down here, I need to select the right VPC. And luckily, I can remember this. We need subnet 3, 4, and 5. These are my private subnets that I've selected here. And I'm going to edit this security group and select an existing one to cheat. I'm going to select this one. And I don't want a public IP on this, so I can disable this as well. I'm not linking a load balancer to this particular service, but what I do want to do, I want my front-end application to be able to find it and connect in on port 6379. So I'm going to enable service discovery. And I'm going to tell it to create a new private namespace. And this is going to be a Route 53 zone. And the namespace is going to be called local. The service discovery name I'm going to use is Redis-master. So DNS-wise, it'll look like Redis-master.local is what I'll be looking up to connect to. And I'm going to give this a 500-second TTL. So let's hit next. And next step again. Skip over this bit, and we're going to tell it to create the service. So, fingers crossed time again. We want to see lots of green here. So we've created a private namespace, we've done our service discovery record, and we've created the service. Now, I'll click on View Service, but I'm going to drop you into Route 53, and I'm going to update this page. You'll notice I've automatically got a new Route 53 zone here, which is local. And if I dig into this, at the moment, because my task hasn't come up yet, I've not got the record for Redis master. But if we drop back to our ECS cluster, we've now got one service created here, and we've got a pending task. So if we wait a moment, what's actually happening in the background now? I've not cheated. I've not done anything with pre-warming any Fargate hosts. This hasn't run for about 12 hours now, so all the infrastructure that was kind of provisioned and held for me in the background's gone away. Fargate is provisioning some instances for me underneath, and it's now pulling these images afresh for me. So it's pulling the Redis image down off of Docker. So there's a little bit of a cold start time here. So if I keep refreshing this, eventually I will get a pending task pop up. While we're waiting for that, I'm going to drop you in, and I'm going to show you the chat service YAML. I'll make this screen a little bit bigger for you as well. So this is my CloudFormation template here. And for those of you who haven't used this before, at the top, we've got parameters. And this is where you can set some defaults or things you can change and tweak in the console as you launch a particular stack. And as we go down, I'll point out some important ones here. I've got one here called desired count. Now this is my chat application. I want to run 3 versions of my task. So I've pre-programmed that in there and stuck it in. We've then got some resources. My resources are things like log groups and a task definition. That's that bit I showed you in the console that I went and turned into a service. But on this template, I've gone one step further, and I've actually cloud-formed my service as well. And this CloudFormation will connect me to a load balancer. It'll run the desired count, which is 3, which I pointed out earlier. So it'll make sure I've got 3 copies of my task running. And another little thing I did, and I added to this, here's a load balancer definition to tell how it's connected up. if I scroll down, I'm going to create a public DNS record. Now, I'm going to create a DNS record called Fargate Chat Digillution.io. I'll put that up a bit later so you can all try and log in and see it. So I'm going to create some DNS as well while I'm creating this. And then this section here is about auto-scale alarms and that. We're not going to demo that today, but I've basically allowed for this particular demo that if we get lots of users in, we can create auto-scale alarms and we'll have more than 3 copies of my task running. And it'll scale back down as well. So we're going to cross our fingers and we're going to go back here. And we've got one running task. Yes, this is going well so far. I've got a Redis server running. And if I have a bit of an update on this, you'll see here I've got a new DNS record. And I've got redis-master.local. And it's got a 10.0.3.25 address. That's in my VPC. And that's the power of the Elastic Network Interface being connected into that task. I've got a real IP in my network. I've not got some obfuscated network that I've got to do some funky routing to get into. Right, let's put the last bit of this up now. I'm going to create this stack, and this one's quite nice because it does a lot of stuff for me and I don't have to do it in the console. I'm going to create my chat service, and I'm going to open that. And in here, the stack name, I'm going to call it chat app, and that's just what my CloudFormation is going to refer to it as. I've got this desired count here, 3. Now I showed you that was in my parameters at the top. If I actually change my mind here and decided I want a 6, I can update it before I hit go. So let's just put it back to the normal 3 and let's go for it. Now this is the important bit. My application takes an environmental variable that gets passed to the Docker container. So if you're doing this on a local Docker install, this is where you have that -e flag, and then you have something called Redis endpoint equals redis-master.local in my case. So this is going to pass that into Docker for me. I'm going to hit next. I'm just going to check I've got everything okay on that. This should be version 3 of my container. Excellent. I'm going to hit next again and skip through this and create. So this will take slightly longer to do. But what I'm hoping for this to create, I'm hoping for it to create me a new task. The task definition that comes up is going to create a service. It's going to make sure 3 copies of that task is running. It's going to register them all with my ALB. And it's also going to create me a DNS record for my ALB as well to make things nice and easy for the rest of the demo. So let's just have a little bit of a refresh on here and we'll see what's going on. You can now see we've got 2 services registered to Fargate and I've got 3 pending tasks. This is my chat application starting to spin up. Now, depending on the day, that can either be really quick like that or take ages. So here we go. We've got 4 running. Excellent. Let's just have a quick check back here. And let's see the progress of this. So there's still some DNS stuff happening and there's still some linking with my load balancer done. So I'm not going to jump the gun and poison my DNS with a record that can't be looked up, which I've done before live. I'm going to wait until this create is finished. I'm going to be a patient person. So this is coming up and it's taking advantage of service discovery. I don't have to take advantage of service discovery. I've got a version of this demo where I spin up an Elasticache cluster for Redis instead. And from that CloudFormation, I actually expose a variable like I did from the production VPC to the cluster. And I consume that in my chat application instead. But I just wanted to demonstrate this new cool feature, which is service discovery. Because a lot of people will say, I need a service mesh for my containers. Well, I would say you've not got a scalable DNS infrastructure that you can use properly if you're looking to use a service mesh. You need to use primitives. Don't make it over complex. Use DNS. That's what it's there for, discovering services. Look at that. We've got a crate complete. This is going well now after the initial test I did on all of you. So I'm going to go here now. First of all, I'm going to show you we've got everything running. It's all looking happy. If I want to dig into this, I can dig into my Fargate chat and I can actually look at my 3 tasks that are running. I can see which version of the task definition they are. You can see I've done this demo 16 times now. And I can see things like I'm running on platform 1.1 and other bits of information that you can customize a little bit. I can also drop out to my logs, and I can have a look at what my logs are pushing out from each task. Why I've only got 2 and not 3, I don't know. Maybe it's just a delay in the console. But the server listing at port 3000, that was put into standard out in my Docker container. It's been picked up by CloudWatch logs, and it's now in this. So, moment of truth, everyone. I'm going to go to Fargate-chat. Is that big enough to read? .digillution.io. And if you go to this on your phones or on your laptops, it will also work. So I'm hoping Brent's going to join at least, and I'll have somebody to talk to on this chat app. So I'm going to go here, and the first thing it's going to ask is, what's your nickname? And I'm going to say Rick, because that's my name. So I hit enter here. I wait for this to resolve on the network, nervously now. Doesn't normally take this long. It's fargate-chat.digillution.io. I'm just going to refresh my page here a second. Yeah, thank goodness for that. Thank you, Josh. It's working. So if I say hello here, we can all see each other typing. First person who types a rude word on, I'm just going to pretend it's not there. Type it in German, I won't understand. So this is our little app working in the background, and I'm not running on any infrastructure. I'm going to prove that. I'm going to go into my AWS console. I'm going to go to EC2 and instances, and this is where I hope I've not left anything running in here. Yes, no running instances. I have no EC2 instances that I'm paying for. I'm just paying for those individual containers running. I've not got to patch anything. I've not got to worry about agents. I've not got to worry about OS updates and libraries being out of date, OpenSSL. All of that worry's gone. Someone's looking after it for me. I'm just looking after my containers. So I've got an infrastructure there by just giving containers to the service. And that lets me just focus on my container. I can now go away and improve the application. So now one of the things we get asked a lot is, how do I get into that container running in Fargate to debug it? The proper answer is you shouldn't ever exec into a container in production to do debug. You should have a proper centralized login structure and collate your logs and use something like Elasticsearch to go through, or CloudWatch logs, and look at your logs properly. Now, I told you I came from a Kubernetes background. I got very, very lazy. Kubernetes has got a very cool tool called kube control, and you can do a kube control exec, give it a container name, and then say bash, and you can drop directly into a container wherever it's running in your infrastructure. Really, really cool. But it made me a very lazy ops person, because I'd go in and debug something on the container. I might do a little bit of a hot fix to make it keep running in production. And then someone would come and talk to me. I'd forget to commit that change back to our Git repo. When all the containers restarted, it all broke again. When I moved to start using ECS for demos, I couldn't do that anymore. And my first reaction was, this is massively frustrating. But then it's like, actually, I'm doing it the proper way now. I've had to look at my logs. There's a problem. Let's go and fix it in Git. Let's do a proper redeploy using my CI/CD pipeline. And it made me a little bit tidier as an admin. So whilst it felt like a constraint, I actually now welcome that to come in. And I don't know, it's something I've grown to love. If the feature was to come out in ECS, I would be very happy, but you've got to ask some of the team about that. So I'll throw that one over to you. Feature requests, this man here. One last thing I'm going to show you, because we've got a bit of time. I talked about our ECS cluster, and I talked about how we could have a hybrid cluster. If you look at the state of my cluster now, I've got no container instances. So if I wanted to move my workload into EC2, so I could SSH to that box and use Docker exec to get into the container and do naughty things with bash, I could. but I don't have any container instances. I can't SSH into Fargate. So I'm going to move my workload and I'm going to try and do stuff. I'm not actually going to move my workload now, but I'm going to show you how easy it is to build a hybrid cluster. So if I go back to CloudFormation here, I'm going to create one last stack, and I'll show you this as well. And I've got ECS cluster YAML. I'm going to open this. That's my cluster name. And I could override the size of my instances here. So I might actually say, I don't want a C4 XL. I'm going to override it in a C4 large. I'm going to have a C4 XL. Mainly because I'm not paying this AWS bill. So let's spin that up. And I'm just going to pick one of my generic Fargate container security groups. It doesn't matter for this particular demo because we're not going to do anything with it. But I'm going to say I want 3 servers on this. So I'm going to go along here. I'm going to hit next. And I'm going to hit next again. Acknowledge that I'm creating some IAM roles here and say create. And what's going to happen in the background here now is CloudFormation is actually going to provision some EC2 instances for me. And it's going to connect them to the ECS management control plane. So my management control plane is going to be dealing with both Fargate and ECS type instances. So when I supply a task, all I do is tell it which launch type I want, and ECS management control plane knows whether to put it on Fargate or to push it out to EC2 for me. So I can move workloads back and forth between the 2 environments as much as I wish. So let's have a quick refresh on here. This might take some time, might not complete, but if we drop into EC2 now, hopefully we'll get some pending instances very, very shortly. While we're waiting for that, let's just drop very, very quickly back to the slides, and I'll show you that at the end. And we'll do a little bit of a wash up here. So I'm going to go. Oh, it automatically switched to presentation mode. Quite impressed with that. So we've seen our demo. We've leveraged CloudFormation. Let's have a quick look at the summary before we drop back to the browser and have a look. So Fargate is a new launch type for ECS. It uses all the same management control plane. It uses the same CLI tools. You can leverage everything you've used before. You can just change one line in it and correct it. Same with Terraform. You just change one line, launch type from EC2 to Fargate, and you can launch. Same integrations with AWS and ECS, apart from the load balancers. There's a little idiosyncrasy there with one being allowed to use elastic load balancers and one not being allowed to use elastic load balancers. Fargate can use ALBs and NLBs, whereas ECS can use ELBs as well. There's very easy migration between the 2 of them. If you're debating whether to use EC2 or Fargate, start off with Fargate. If you've got a need to then drop into your containers and do extra things or tweak kernel parameters, that's when you move to EC2, I would say. Don't give yourself the heavy lifting of managing worker nodes if you can avoid it. Concentrate on your application. If you really, really, really have to have that underlying access to Fargate, it doesn't work. I talked about the good reasons for not being able to get in, but I talked about the hybrid clusters as well as a get-out-of-jail-free card there almost. If you need to move it to EC2 so you can get into a container, you can do. And you can start using Fargate today in US East 1. It's great. It's great fun to play with, and it's super simple just to get started. Even if you're not going to CloudForm it, log into the console, switch to North Virginia on your region, and click Launch Cluster, and it's there. The best bit about that is, as long as you're not running any containers, there's no bill associated with that as well. So you can at least have a play around the command line tools and get familiar with what's there. I mentioned this before. This is Nathan Peck's GitHub account. If you go on here, it's a big list of instructions and tutorials and demos and explanations about networking. As you scroll down this, you can click whether you want to talk about Fargate or ECS. You can pick whether you want a public deployment of ECS or Fargate, or you want to run in a private network, and it will give you different instructions of how to do that. It's a great set of resources, and I relied on this heavily so I could ramp up on this product, so it's great to have a look at. Let's drop back quickly to our slide, our browser, and let's see if our CloudFormation's finished. Right, I've got some instances starting. So my CloudFormation has created me 3 instances. It's nicely spread them out in US East 1A, 1B, and 1C. They're just starting up, so they may have not registered themselves with the cluster yet. We've got no data back from it yet. But now I've got here 3 container instances. So my one Fargate, my one ECS cluster can now launch both Fargate workload types and EC2 workload types. So I've got a hybrid cluster very, very quickly and very easily. So have a play about with that. It's great fun to play with, and you'll get extra memory and CPU utilization once all this registers itself, so you can see how much of EC2 you're using. The thing to think about with EC2 is you're paying for the instances underneath. Fargate, you're paying at a container level. So that's worth taking in consideration. I've only got one last slide for you. So here we go. Thank you very much. aws.amazon.com/Fargate. Do feel free to reach out to me on Twitter and ask me any questions. And thank you very much. I hope you enjoyed that session. Cheers.